Hi everyone, today we're back for a video on oxygen not included, and today we see the steam turbine. We see how we can use it and what we can use it for. First of all, we cannot place the steam turbine as we want, as we would normally do with another building. If I try to place it here over the floor, we can see that it's not going to work. I need to use the floor in order to separate the inlets of the steam turbine and the steam turbine itself. So if I do that, we can see that I can place the steam turbine. The steam turbine is going to consume steam in order to produce energy. So what's going to happen is that here at the bottom, close to the inlets, there will be steam, and thanks to its inlets, the steam turbine is going to consume the steam and produce power thanks to that. It will also emit water. So if we look here, we can see that we have an output for the liquid, and it will output water at a temperature of 95 degrees. So if we have a steam at a temperature of 125 degrees and the water is outputted at 95 degrees, that means that we have deleted the heat by 30 degrees. So the steam turbines allow us also to delete heat. So now how can we get steam? Because we need steam in order to make that steam turbine function. Well, in order to have steam, we can look at the property of the polluted water and the water as well. And we can see here that when it reaches 119.4 degrees, the polluted water will turn into steam. And for the water, it's a bit different. The temperature is not exactly the same. It is 99.4 degrees. It turns into steam. So when this temperature will be reached, the polluted water and the water will turn into steam. So in order to see that, I will heat the water here. And we can see that it turns into steam. So if I heat it a bit more, we'll see the other water is going to turn into steam as well. And now we only have steam in our room. And we can see that the steam turbine is consuming that steam and is producing electricity, producing energy. We can see that now it's producing 850 watts. So that is the maximum it can produce. And it's also releasing water. We can see here that it's releasing water, and the water is at a little bit less than 95 degrees, so it's ejected at about 95 degrees Celsius. And then the water comes back here and turns back into steam because it is too hot, but that allows us to cool down the heat that is in that room here at the bottom. The way I heated up the water is not really realistic in a real game, so you will need to find a way to heat up that water in order to turn it into steam. So one way could be, for example, to use an aqua tuner that produces a lot of heat, or to use other machines that produces a lot of heat and release that heat in that room here in order to turn this water into steam and then keep that steam hot enough so it can make the steam turbine work and generate power. There are two factors that affect the steam turbine's power productions. So one of the factors is the mass of steam that it consumes, so the quantity of steam that it consumes, and the temperature of that steam. So each inlet here at the bottom can consume 0.4 kilogram of steam, and so given that there are 5 inlets, it can consume up to 2 kilograms of steam per second. I've put an airlock here, so it's going to block one of the inlet of the steam turbine, and we can see if I start the game again, it's not the steam turbine is not producing 850 watt anymore. It's only producing 650 watt. So it's reduced because, as we can see, also we have a message: 1 out of 5 inputs is blocked. So 1 out of 5 of the inlets is blocked. So that can consume less mass, less steam, only 1.6 kilogram in that case. So for that reason, it can produce less energy. I've now removed the airlock. So we have all the 5 inlets free in order to consume steam, and we'll see what happens. I will restart the games, and we can see that the steam turbine is now producing 850 watt, which is the maximum it can produce. But we can also see that the steam temperature is going down little by little, and as it goes down, we can see that the steam turbine's production is going down as well. We are already only at 467 watt produced. So that shows that the lower the temperature of the steam is, the lower the production of the steam turbine is, and the less energy it will produce. It also shows that the steam turbine is deleting heat because the steam here in that room is decreasing in temperature. So it's decreasing in temperature because the steam turbine is releasing water at 95 degrees, so it's consuming steam, and then it's releasing the equivalent in water, but only at 95 degrees, so that water is being ejected here in that by that liquid vent, and it turns instantly into steam, but it cools down all the steam in that room little by little. As you can see from this array, the hotter the steam is, the more heat will be deleted by the steam turbine. So in order to understand how much power the steam turbines will produce, there is a formula. So this formula takes into account the mass that it takes in, so of course depending on the number of inlets that is available, as well as the temperature of the steam. So M is the mass, T is the temperature of the steam, and P is the power produced. We can also modify that formula in order to find the temperature. So that way we can find the temperature based on the mass that we have and the power productions that we expect or that we want. So let's take an example. Let's say we want to produce 850 watts and we are willing to consume 2 kilograms of steam per second. So in order to do that, that would mean that we need all our inlets free. And if we have these two factors, if we take these two factors into considerations, that means that we would need our steam to be at a temperature of 200 degrees in order to have our steam turbine to produce 850 watts of energy. So don't worry, you don't need to figure out every possibility. There is already an array that summarizes different possibilities, and also it's important to note that if only one inlet is free, and so that means that 4 of the inlets are blocked, this formula doesn't apply exactly the same way, it works a little bit differently. To sum up, if the temperature is below 200 degrees Celsius, you probably want all the inlets to be unblocked in order to maximize the power generation. But if the temperature is above 200 degrees, you probably want to block some inlets in order to reduce the steam consumptions without affecting the power generations. So probably if the temperature is above 200 degrees, you want to maybe block 1 or 2 inlets because you will not have your power generations affected. It's still going to be 850 watts depending on the temperature of the steam, but you will consume less steam in order to get that power generation. In order to work, the steam turbine needs to have a steam at a temperature of at least 125 degrees. So here our steam has decreased to a temperature of 116 degrees, and we can see that the steam turbine doesn't work. It refuses to work, and that's because the steam is too low in temperature. We can see here we have a message that the steam temperature is below 125, and that's why this generator is idling. We can also notice that the steam turbine produces heat and its temperature is increasing little by little. So we can see that it's going over 100 degrees, and when it's reaching 100 degrees, you can notice that the steam turbine stopped working. So here we can see that it says that the steam turbine is too hot. So we have that message, and that means that we will need to cool that steam turbine in order to keep it working 100% of the time. So we can use the steam in order to delete heat, but that doesn't leave us a lot of options to cool down machines or areas because we can only cool down that steam. So in order to have more options, we can use the thermo aqua tuner. So this thermo aqua tuner will allow us to take a liquid as an input, and it will output this same liquid but at a lower temperature, so it's going to cool down that temperature. However, that's not enough to enable us to cool down everything. We will need also to use radiant pipes. So here we want to cool down the area around the steam turbine, so there could be other areas that we would want to cool down, but this is the only area that we want to cool down in this case. So if I activate the overlay, the plumbing overlay, we can see here that I've used radiant pipes, and what does these radiant pipes do? They will transfer the heat faster, so there will be a better heat transfers between this wire here in the pipe and the gas that is outside. So in this case we have polluted oxygen, but it could be any gas. We can also notice that the rest of the plumbing network is made of insulated pipes, and that's because we don't want to lose the code in other areas. So I don't want to lose this code here, for example, in these areas, and I want to keep that code in order to maximize the heat transfer in the area that I care the most, which is around the steam turbine. These pipes contain water. They could contain any liquid, so it could contain, for example, polluted water. The advantage of polluted water compared to water is that it has a lower freezing temperature, so you if you run into problems that your pipes are breaking because the temperature is too low, for example -2 or -1, polluted water will help with that because the freezing temperature is lower than that. You could also use supercoolant, which has a very low freezing temperature, but supercoolant is harder to get in the game, so as an early option it's probably better to use polluted water. So how can we ensure that the water is not too cold, that it reaches its freezing point, and then that it freezes and basically breaks your pipes? Well, we can use a liquid pipe thermosensor in order to do that, and we can set these thermosensors at a temperature that is high enough so it never reaches that point. So here, if I look at the aqua tuner, we can see that it's going to cool by minus 14 degrees, so your water will be 14 degrees lower once it's outputted by the thermo aqua tuner. So that means that if I put it like 15 degrees over the freezing point of the liquid that I use, I will never run into problems. To achieve that, we need to use an automation wire in order to connect these two machines, so the thermo aqua tuner and the liquid pipe thermosensors. We need to make sure that our liquid flow is not interrupted, because the aqua tuner, when it's going to be disabled, is going to stop consuming water, and therefore it's going to stop outputting the water as well. But the problem is that that could happen is that if you have water here or any other liquid that is meant to cool down the external gas, little by little the liquid is going to heat up and is going to reach the same temperature as the gas that is outside. But the problem now is that it's not cooling anything anymore because it's the same temperature. So in order to solve that problem, we will need to make sure that the flow is not interrupted. We can achieve that by simply connecting the plumbing network just after the entry of the aqua tuner and link it with a bridge to the rest of the network. So here what we have the water that comes in here and is going to be consumed by the aqua tuner, and if it cannot be consumed by the aqua tuner because it is currently disabled, it will continue and it will go to that bridge, and it will go through that bridge and continue in the flow. And if it goes through the aqua tuner because it's enabled, it will simply enter in the aqua tuner's entry and leaves by this aqua tuner exit, and it will continue in the network normally as well. That way, even if the liquid is below the threshold that we set on that thermosensor, it will not interrupt the flow. The aqua tuner will stop consuming that liquid, but this liquid will still be able to flow over that bridge and continue to flow through the plumbing network. This is basically how the steam turbines works. We can see that it goes well with the aqua tuner because the aqua tuner gives us more options on what to cool and where to cool it. We can obviously extend the radiant liquid pipe network in order to cool down a larger area, but that would also increase the temperature of the liquid inside the pipe. So we need to make sure that the aqua tuner can keep up with that temperature, with the temperature deletion, because it can cool down only 14 degrees. So as long as the temperature is not increasing by 14 degrees over the whole cycle, that will be fine, and the aqua tuner will be able to keep up.